How keypad works. In this tutorial, we'll explore how Matrix Keypad works. On the screen, you can see a 4x4 matrix keypad consisting of 16 keys labeled from 1 to G. For simplicity, we assume that only one key is pressed at a time. In this keypad, the first terminals of the keys in each row are electrically connected and linked to a digital voltage source. The second terminals of the keys in each column are also connected together and wired to LEDs. Let's examine how the keys function. When we press key 1, we apply a logic high to the first row. We observe that the LED in column 1 lights up. This indicates that the key at the intersection of row 1 and column 1 has been pressed, which is key 1. At this point, the row input is 1 1 0 0 0, meaning only the first row is high and the others are low. The fact that only LED 1 is on confirms that this binary value 1000 has been detected at the output through the column line. Next, we press key A. We sequentially apply a logic high to the first, second, and then third row. When the third row is high, the LED in column 2 turns on. This tells us that the key at the intersection of row 3 and column 2 has been pressed, which is key A. Here, the row input is 0010 and the column output is 0100, meaning only LED 2 is on while the rest remain off. So, how does this system work overall? We scan the keypad by rapidly applying a logic high to each row, one at a time, while reading the status of columns. By comparing the binary value applied to the rows with the binary value read from the columns, we can identify exactly which key has been pressed. This principle allows us to write a program on a microcontroller that can detect any key press on keypads. The diagram illustrates that the rows are scanned continuously and rapidly, one after another, in a loop. When no key is pressed, none of LEDs turn on. But as soon as a key is pressed, the LED connected to the corresponding column lights up, indicating a valid key press.